It's totally unstable. It's going to explode. No, giving me is not going an amazing chance to go for that. The thing is, it might be tomorrow. It very well might be during this transmission, and it would shimmer like a subsequent sun above the James Webb Telescope. As of late, it has identified a surprising 250% extension in the brightness of creepy crawly Jew, the red star arranged at the shoulder of the Orion heavenly body. This flighty way of behaving has touched off energy for fascinating showcase. Some recommend the unexpected expansion in brilliance could demonstrate that Bug Jew is getting ready to go supernova. Yet the specific timing remains unsure. Experts estimate it could work out soon. Join us as we explore the profundities of space and unwind the mysteries encompassing this divine giant. Creepy crawly Jew has the potential to reshape how we grasp the universe. In spite of its name not being commonly known, you've likely praised its splendor. A splendid reddish sparkle radiating brilliantly at the shoulder of Orion, a prominent star gathering. Scarab Jew's hugeness is faltering when set at the core of our nearby planet group. Its external surface would reach out past Jupiter's circle. This monster star, effectively perceptible, continues to captivate us. Dissimilar to most stars, Scarab Jew changes in splendor over time due to its closeness to our framework. Named a semi-regular variable star, its brilliance changes reliably, pushing toward a potential incredible breakdown in a cosmic explosion blast. As of late, Scarab Jew has become even more enamoring due to amazing changes in brilliance. These differences remember a critical flood on May 20th, 2023, when scientists noticed an amazing 142% increment in brilliance, followed by a later update showing a 150% increment. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Creepy Crawly Jew presently positions as the 7th most brilliant star in the night sky, climbing 3 spots from its standard 10th position. From the southern portion of the globe, Betelgeuse sparkles brilliantly in the early evening sky, effectively noticeable at the shoulder of the Orion gathering of stars. Dr. Sarah Webb, an astrophysicist from Swinburne College of Technology in Australia, highlights Scarab Jew's importance. It offers an intriguing opportunity to concentrate on the last periods of a monstrous star's life, giving important experiences into red giant's conduct before they detonate as supernovae. When Creepy Crawly Jew ultimately explodes, it could turn out to be unquestionably brilliant for about 7 days, potentially projecting shadows around nighttime. This prospect has both beginner stargazers and expert cosmologists enthusiastically anticipating the event. Heidi Morris, a specialist at Los Alamos National Laboratory and president of the Pedaro Space Experts and Cosmology Club, noted the persevering interest in Creepy Crawly Jew's brilliance changes, a peculiarity inconspicuous for a long time by various societies. Right now, Scarab Jew's brilliance cycle goes on for around 130 days, substantially more limited than its standard 400-day cycle. These quick changes give stargazers an extraordinary opportunity to concentrate on this divine peculiarity in detail, revealing insight into the last phases of a star's life. The astonishing conduct of Creepy Crawly Jew began in 2019, at the point when it viciously launched out a piece of its external air. These variances in brilliance are unusual for insect Jews, raising questions about whether it will explode into a supernova. According to a paper composed by Dupree and other scientists from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse gets back to its generally expected 400-day brilliance cycle, since the limit obscuring of Bug Jew has shown its conduct concerning light and outward speed has adjusted. Regardless of its impulsive conduct, Scarab Jew remains a huge red supergiant star going through the last periods of rapid development as it exhausts its fuel. The center will fall under its tremendous mass, bringing about a cosmic explosion impact that could shroud whole systems. The timing of this impact is questionable, as indicated by Dr. Doc, a professor of cosmology at the University of Portsmouth. Predicting cosmic explosion events remains challenging, given the limited historical data and the intricacy of stellar evolution. Bug Jew is currently going through fusion processes, constantly developing through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon in its center, a cycle that takes millions of years. Eventually, it will advance to fuse heavier components until it can no longer support fusion reactions, prompting gravitational breakdown and potentially forming a black hole or a neutron star. While some speculate about creepy-crawly-Jew's impending blast, historical records show it has been becoming redder over the past 2,000 years, suggesting it could take considerable time before it goes supernova. NASA estimates proposed that Scarab Jew isn't supposed to detonate for another 100,000 years, offering consolation that its blast is improbable to happen within our lifetimes. Disregarding the vulnerability in Jew's conduct, it continues to captivate specialists and motivate progressions in how we might interpret stellar evolution. Dr. Sarah Webb reminds us to remain open to potential outcomes, even as we recognize the unlikely probability of seeing Bug Jew's blast within our lives. Staying aware of its changes may lead to additional scientific breakthroughs, reminding us to keep hope alive for new discoveries in the universe. It's vital to understand that our observations of creepy-crawly Jew are essentially glimpses into the past. The light we see from the star is over 600 years old. Hypothetically, insect Jews might have already detonated, and we wouldn't yet know about it. While this chance exists, it is far from certain. History has shown us that our assumptions in space science can be challenged. Preceding 1987, astronomers believed only red supergiants could go through supernovae. Anyway, that year, a gigantic blue star in another galaxy detonated, astonishing the intellectual community. There is still much to learn, and surprises might lie ahead. Noticing creepy-crawly Jew and other enormous stars permits us to expand how we might interpret stellar phenomena. No matter what the absence of an approaching blast, Bug Jew's ongoing behavior is captivating. Its fluctuation between dimming and emitting uncovers entrancing physics. The reality that stars throb on human timescales is amazing. While Betelgeuse is presently much brighter than anticipated based on its normal multi-day cycle, there's hope it will ultimately return to this cycle. Anyway, it is attempting to do so. Later observations have suggested that Betelgeuse might be in a late stage or moving toward the end of the core carbon-consuming cycle. This stage involves the transformation of carbon into heavier components like oxygen and magnesium. If this is indeed the case, scientists foresee a core collapse leading to a supernova blast that could occur within a few years. Anyway, the exact phase of insect Jew's evolution remains difficult to determine, and uncertainties persist. The chance of seeing creepy-crawly Jew's blast remains unclear, as the carbon-consuming stage can last up to 1,000 years, and the study suggesting an imminent blast has not yet been accepted for publication. Regardless, considering the potential for Bug Jew to become a supernova is exciting. It would be an exceptional event visible even during the day for several days. When the event arrives, the starting signs of the cosmic explosion's appearance will be subtle but undeniable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of stellar debris. Scarab Jew will progressively grow brighter in the night sky, possibly reaching peak brilliance 10,000 to 100,000 times its normal splendor within only a few weeks. This scene will stun anybody fortunate enough to witness it, marking a critical moment in cosmic history. The remnants of creepy-crawly Jew's blast could be as brilliant as a quarter or half of a full moon, packed into a single point of light. Incredibly, this brilliance would be visible during daylight, creating dramatic shaded areas at night. Forecasts suggest it may be 15 to 100 times brighter than Venus, currently the second brightest object in the night sky. The display of insect Jew's blast would linger in our view for around 100 days, enthralling space lovers and offering a unique opportunity to observe the outcome up close. Luckily, Scarab Jew's supernova wouldn't pose any threat to humanity, as it is still fundamentally far away. Optics and telescopes would allow us to notice the event for an extended period without harm. Anyway, such a sensational event wouldn't go unnoticed. Supernovae were often interpreted as ominous signs, and Bug Jew's death could stir fascinating responses around the world. Astronomers believe it could even raise widespread interest in stargazing, awakening people from their ignorance on a global scale. Creepy-crawly Jew isn't the only red supergiant in our galaxy. Others, like Edi Carni, could detonate before it does. Truly, our Milky Way should witness a supernova roughly every 100 years, but we haven't seen one in the last 400 years. Anyway, we've noticed the remnants of past blasts, indicating that we are overdue for a significant cosmic event. It's only a matter of time before the next star puts on its monumental act for the universe to observe. Betelgeuse's history is rich with significant events, including the dramatic dimming in the fall of 2019. This sudden decrease in brilliance confused cosmologists and ignited speculation about its potential blast. Although Betelgeuse's brilliance returned to normal by April 2020, the reason for its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily spot creepy-crawly Jew from their own homes, making it an accessible cosmic entity to engage with. If the supernova occurs, we are sure to witness an incredible celestial performance. As we continue to monitor creepy-crawly Jew, the star remains a beacon of intrigue for both professional astronomers and amateur skywatchers alike. The ongoing changes in its brightness offer us rare opportunities to study the processes happening inside a dying star. With advanced technology, scientists can now analyze the star's behavior with a level of precision never before possible. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are helping unlock more secrets about this stellar giant. The study of supernovae, like the one that Betelgeuse might eventually become, has far-reaching implications beyond just understanding the end stages of a star's life. These explosions are critical for the formation of elements heavier than iron, which are necessary for the creation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the very building blocks of the cosmos, enabling new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova in our lifetimes, it would offer a unique and stunning opportunity to observe such an event up close. For those fortunate enough to witness it, it would be a once-in-a-lifetime spectacle. The light from the explosion would outshine all other stars, briefly becoming a fixture in our sky, while astronomers race to capture the data. Interestingly, this possible supernova won't be a threat to us on Earth. Despite Betelgeuse's massive size, the distance between us and the star ensures that any radiation emitted by the explosion would have little impact on our planet. Instead, the supernova's influence would be felt most by scientists and space enthusiasts observing the phenomenon as it happens. This could fuel further advances in space exploration, encouraging more research into stellar evolution, cosmic explosions, and the mysteries of the universe. Regardless of when it happens, Betelgeuse's eventual explosion will be a critical event for astrophysics, expanding our knowledge of star death and the life cycles of massive stars. The spectacle may also inspire future generations of astronomers, fueling curiosity about the universe and encouraging people to look up and wonder at the vast cosmos. Betelgeuse, the bright red supergiant star in the constellation Orion, has long captured the attention of astronomers and stargazers alike. Located roughly 640 light-years from Earth, it is one of the most famous and visible stars in the night sky. However, its recent behavior has sparked excitement and speculation among scientists about the star's eventual fate. Astronomers have observed significant changes in Betelgeuse's luminosity, suggesting that it may be nearing the end of its life. Its irregular variations in brightness, along with massive ejections of gas, have led to the hypothesis that Betelgeuse might be preparing to explode as a supernova. If Betelgeuse were to go supernova, it would be an extraordinary event. Supernovae are incredibly powerful explosions that occur when a star's core collapses under its own gravity, triggering a massive release of energy. This explosion can outshine an entire galaxy for a brief period, releasing more light than the sun will in its entire lifetime. A supernova is not only a spectacular cosmic phenomenon, but also a key process in the creation of elements necessary for life. These explosions scatter heavy elements like iron and gold across the universe, contributing to the formation of new stars, planets, and eventually life itself. The potential for Betelgeuse's supernova is of particular interest to astronomers because it offers a rare opportunity to study the final stages of a massive star's life. While stars like the Sun will evolve into white dwarfs, Betelgeuse is a much more massive star that will eventually collapse into a neutron star or black hole. By closely observing Betelgeuse's behavior in its last years, scientists hope to gain insights into the physics of stellar death. As the star nears the end of its life, it undergoes a series of changes, and the processes occurring inside the star are still not fully understood. Given Betelgeuse's erratic nature, Scientists are watching it carefully. Its recent flares of brightness suggest it could be in the final phases of its evolutionary journey. While the exact timing of a supernova is uncertain, experts speculate that it could happen within the next 100,000 years, although it may happen sooner.
The difficulty in predicting the exact moment arises from the fact that stellar evolution, particularly for massive stars like Betelgeuse, is still a topic of active research. Astronomers also face challenges in predicting how stars will behave in the final moments before their collapse. For now, the growing intrigue around Betelgeuse remains a source of excitement and wonder. With cutting-edge instruments like the James Webb Space Telescope now available, scientists are able to observe the star with unprecedented precision, analyzing its behavior in great detail. Observations of Betelgeuse's light curves and mass ejections may reveal new information about the processes that govern the death of massive stars. These discoveries not only advance our understanding of stellar evolution, but also have profound implications for our knowledge of the universe's formation and the origins of the elements that make up everything around us.